Hey there, what's up? I'm going to show you how I made Spooter in Unity, and specifically, we're going to look at the code. Now, I'm assuming that you know what Spooter is, okay? I'm assuming you saw the game design video that I did about Spooter. If you didn't, you should. It's about 10 minutes, and should be somewhere around in a note that you just check that out. First, I'm assuming you know how the game plays and what's the thought process behind it. So I'm actually going to show you how I built it in Unity. With that said, I'm showing you a complete product. I'm showing you the end of the development process. This is not going to be a step-by-step tutorial, okay, starting from scratch and reaching something. It's not going to be that. I'm showing you what's at the end of it. So if there were hiccups in the development, clearly it was a process, then you don't get to see those things. You just get to see how I actually made the game. So again, you should be familiar with the game, and you should probably play it a little bit too. I think it's fun, so yeah. Before we go in, I have to mention one more terrible disclaimer. I'm not a code wizard, and I am not an expert in Unity. I'm still a student of this engine, and I am still, well, nobody never becomes a complete master of anything. But I'm still just learning, so I may do things that are not correct, that I did them, and there's better ways. And if you know of any better ways to do something, please let me know, because I'd love to learn. Do not take anything that I do, or even anything that I say, as an ironclad rule, because it isn't. I am still fumbling my way around, and I just made this in 48 hours, so there's a lot of things here that is just kind of, whatever, it worked, whatever, let's just go, let's keep going. The point was to make this and have it work, and just make it as quickly as possible. And I did make it in 2 days, not really 48 hours, it's more like 2 days on and off. So, yeah. This is probably going to be a while, and going to take a long time. I'm not going to feel terrible about this video being pretty long, and I'm probably going to screw up quite a lot, so bear with me. Okay, let's get started. The actual scene of gameplay, I'm going to show you the other ones as well, don't worry, but if we're going to look at game, okay, I got 3 scenes. If I close down everything, I got 3 scenes: game, how, and menu. The menu is the main menu, how is how to play, and game is game. Okay, so what do we have? We have the player. This is the player. It's a triangle. All right, it's a sprite render triangle. You can see it here, though my face hides part of it, but that's just a triangle. And it has a sprite render, a transform, a rigid body. This is important to note that the gravity scale is 0. What I'm using the physics for is collisions and movement, but there's no gravity. So the gravity scale is 0. I could just go to physics 2D settings and change the gravity itself to 0, and then this could be whatever the hell I want, but I just change it on the rigid body themselves because that's just the way that I did it. That's the rigid body. We've got 2 scripts, which we'll clearly talk about, and we've got the circle collider. The reason I chose a circle collider is because we're spinning, so it makes more sense to me that there's a circle collider than an edge collider with just 3 edges, as triangle or box collider. So I just chose a circle because it makes sense to me with spinning around. What else do we have in the scene? We have the spawner, which clearly, again, we'll talk about. There's only one spawner, and it just moves around randomly and spawns things. We'll see that as well. Main camera, I didn't change anything other than background color and the size of it, I guess. GUI, which is just an empty game object with the GUI. And then we got 4 borders, which are exactly those borders. I hope you can see those. Just a border, 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 and border. And then destroyers, which are just a little bit after the borders. The reason we have these destroyers is because when I'm shooting out bullets, I'm instantiating a lot of game objects that are these bullets. And once they leave the screen, the screen for me is the borders, right? The borders inhibit me from leaving the screen, the player that is. Once the bullets leave the screen, I don't need them anymore. They serve no purpose, and I need to destroy them. I don't want to have, a ton of game objects in my scene. So I just destroy them with destroyers. All right, so let's get started with the main script, I'd say, of the game, which is Spooter. Right? It's called Spooter. It's Spoot stuff. I'm using Visual Studio here, and I made the font a lot bigger so you could comfortably see what the hell's happening here. My naming convention is I'm kind of screwing up because other scripts don't have this naming convention, but it was kind of something I did a long time ago, and I just kind of that's how I learned when I learned coding initially, to have the first letter as something. So this is a float, so you have F at the beginning. I don't know, it's cute these days. It's not really that useful these days, you don't really need it, but I used it here. So yeah, sue me. Okay, so the shoot force, we'll see that it's the force that you actually shoot stuff. Maximum movement speed and minimum movement speed, we'll see those come into effect in the function, the speed at which you move. If you remember, you do move faster when you're not spinning and slower when you are spinning. So everything is a function of your rotation. We have the maximum rotation speed, which is 25. The minimum is 0. So I just don't have a value for minimum because it's just 0, so I just didn't have it. The actual movement speed, this is a value that changes. The timer for shooting and the shoot delay, both of these change actually. The shoot delay is, I count up, I have this a lot, so it's important that you realize how it works now. Not very complicated. I have a timer, it starts at 0, counts up to the delay, up to the point that I'm counting at, and then we zeroed it, and it keeps on counting. Okay? I hope my hand gestures explain what the hell's happening. So that's just what I'm doing, and the rotation that clearly also changes. Spooting tells me if I'm spooting, which is spinning and shooting. And I have the game object of the bullet prefab because I'll be instantiating bullets, so I need the prefab. It's a good time to take a look at the prefab. It is a sprite renderer with the circle, a circle collider, duh, and a rigid body that again also has the gravity to scale 0 because we don't want the gravity to affect. What I do with these, I instantiate them exactly where I am, and then I give them a force to fly away, and that's pretty much it. I just give them a force once. I don't need any script to maintain it because I just throw them out. Alrighty then, let's go back to spooting. Okay, so in spooting I have a couple of functions, and we're going to start in whatever order we've got. Yeah, the shortcut, I'm 100% positive someone will ask me. The way to close down all of these is Control M and then O if you're using Visual Studio. The reason I'm using Visual Studio and not Mono is because I have Visual Studio. Why would I use anything other than Visual Studio? This is 2010 with ReSharper. It's, you know, I'm biased because I like this, and some people would argue, but for me this is the best development environment in the world. And whatever you say, it's better than Monodevelop. So no offense to Monodevelop, but this is better. And I just really like it. Okay, so update. You have update and you have fixed update. Fixed update updates every frame. Updates runs every time that it ends. So when update ends, it starts again immediately, and this could actually happen a couple of times a frame. It could actually happen. So this is fixed every frame, and this isn't. The reason to use any of them is usually anything that you want to be very, very precise about, you know, direct inputs should be an update. And fixed update, I usually use for axis-based movement. Okay, the axis is input when you do, you know, the arrow keys or WASD, the axes go from 0 to 1. This is the horizontal input and the vertical input. So they go from 0 to 1 in the axis of horizontal and vertical. This is stuff that you, it's in input, yeah, input, the axis, right? Horizontal and vertical. Basic Unity movement and input. So this is what I usually use at. Let's actually take a look at fixed update. The movement speed is a function of rotation. We'll see this, we'll talk about this lovely math explanation in a second. And then the velocity, what I actually do, I just give myself a velocity. The rigid body, this is my rigid body, the player itself. I give myself a velocity, either right or up, times the horizontal input, which is somewhere between -1. This is actually not true. It's somewhere between -1 and 1. It's somewhere between -1 and 1. Okay, so -1 is left and 1 is right. -1 is down and 1 is up. All right, this is more. I hope you can understand what's here. That was actually misleading. So this actually gives me the direction, and then times my movement speed, which is actually the force at which I'm moving. And that just sets my velocity to move around in both axes. This is my entire vector of velocity. So the movement speed is a function of rotation. When I say a function of rotation, I don't mean a function. I mean a function in math is you give it variables and you get a result. That's a function. You give something, you get something. It's like a function in coding, right? So this is the only thing that actually changes. The reason that these are actually constant, the reason that they're not constant, usually you write constant in all caps, is because they're public. You know, some of these are public and private so that I could actually change them inside and test things out. This is very, very useful. You can, you know, play and change these and test these out as you test the game. So that's why they're public, and a couple of them are private for no reason. You know, I could actually change these to constants now that the game is completed, kinda. So this never changes. The maximum movement speed, minimum movement speed also doesn't change, and this is my maximum rotation speed, which is 25. The only other variable that should be here is the minimum rotation speed, but it's 0, so it just kind of disappears here. Now notice the way that it works. Remember, if my rotation goes up, then my movement speed goes down. So higher rotation, lower movement speed. Lower rotation, higher movement speed. So if I want to get just the maximum movement speed, if my rotation is 0, this whole section, okay, I'm not sure, you can't actually see my mouse for some reason. You can see my mouse here, but you can't see my mouse on Visual Studio. Kind of weird, but you can see what I'm holding, right? Yeah, you should be able to see that this whole section is highlighted. So if my rotation is, if only this part is 0, this whole thing becomes 0, and then my movement speed is just my maximum movement speed. If this is, usually it'll be 25, you know, if I'm a maximum rotation that I have, then this whole thing will be minus something. It'll be minus, depending on what my minimum is 4.5. So this whole thing will be minus 3.5. Minus 3.5 plus the maximum, which is 8, equals 4.5, which is my minimum movement speed. Hopefully that point passed through. It's kind of difficult to explain this math, but that's just how it works. Okay, we have a couple more of these to explain, so we'll have to do this properly as I stretch my neck. Ugh, okay. So that's fixed update. That's how movement speed, faster rotation, slower movement speed, slower, no rotation, fast movement speed. Okay, that's fixed update. Update. Get mouse button down. If I click the mouse button, then I am spooting. If I let go of the mouse button, I am not spooting anymore. That's all I'm doing. Note that this is mouse button down and mouse button up. There is also a function of mouse button. This function just lets you know if the mouse is currently pressed. Mouse button down will only trigger at the press. When you press, will only trigger once, and up will only trigger as you let go. All right. So I'm always spooting, but what this allows me later on to do is to simulate this thing, simulate letting go while I'm still holding the mouse button. It allowed me to still hold the mouse button down, but set spooting to false, where I'll stop, and that will force me to let go of the mouse and then click it again in order to start spooting again. I do that later on. We'll see that. So I know if I'm spooting or not. Now I need to shoot and I need to spin. Both of these functions are just, I split them up because it's more comfortable logically to think about it in that way, but they are tightly woven because everything is a function of spinning really. And I just put them here. Both of these are functions that run within update, and then I can use, you have to remember that I can use things that update does. What's a thing that update does? We can use time.delta time. So let's go ahead into shoot. Time.delta time. This is a timer, okay? Delta time is the time between the last run of update. Really, it gives me the time between those. So this is a counter. This will count time up in the most basic form there is. So I'm counting up time, and I use these a lot. We're gonna see this a lot. I count up the time, and if my shoot timer, which I count up, has passed my delay, okay, is bigger or equal to delay, and I'm also spooting, which is shooting and spinning, then I am going to shoot, and this is shooting, okay? So this is my shot delay. I keep counting up, and then clearly when I go in, I zero it. I reset it. The shoot timer goes back to 0. And now I'm setting up for my bullet. So I get the mouse position. I get the mouse position. Remember that this is me and I shoot with the mouse, right? So I get the mouse position, and I get the mouse position. It's kind of weird that you can't see my mouse. It kind of makes this whole thing kind of weird. So you know what? I'll use the arrow keys to make it a little bit better. So I need to make sure that I have the screen to world point, okay? Because my mouse is on the screen. I need to get the world point. So this is how you do it. You get camera.main screen to world point, input mouse position, and I have the mouse position. Now I need the direction. Okay, I need the direction from me to the mouse. So this is just the way you do it with basic vectors. Mouse position minus my own position with transform.position, and that gives me the direction. Now we create the bullet. I could actually do this in different orders, but that's just the way I did it. You know, I could take this entire thing and put it over here. It doesn't matter. I create the bullet, instantiate bullet prefab where I am. That's it, and I keep it. I keep the game object because I want to give it a velocity. And something really, really cool, I want to add force to it, that is. I want to get it moving. Something really cool happened here, and it took me a while to understand what happens. You could read this, or you could let me just explain it. What I do here is I normalize the vector, and then which should give me the direction, and then I multiply it by a shoot force, which is a constant. It's always 2000, and that's it. And you'd expect it to always be the same force shooting out. Now, if you've watched the game design video, you know that that's not the case. What actually happens here, okay, if I'll play just for a second, if I shoot really close to me, they come out pretty slowly. If I shoot far away, they come out very, very, very fast. Okay, it's the force at which they come out, not the delay. The delay is always the same. So how does this happen? Notice that this is a vector 3. Okay, and it took me a while to figure this out. This is a vector 3. And I am using only x and y because I am in a 2D plane. When I normalize a vector 3, it normalizes the vector as it normalizes x, y, and z. It normalizes all three. But I'm not using z. I'm using only x and y. So the end result is not normalized. It can get all types of values. If you're not familiar with what normalized does and how vectors work, a vector is really just it has three values, x, y, and z, and what it signifies in most cases is a direction, and it also has a type of length, okay? It has a magnitude. When you normalize a vector, its magnitude is 1. It goes down to 1. The direction is kept, but the magnitude goes down to 1. So if I want just the direction, which is what I want here, what I wanted to do here is have the direction and then add force. Always add the same force, get the direction, add the same force. What I actually get here, because I'm normalizing x, y, and z, but then only using x and y, I do get different values. The magnitude isn't always 1. It's somewhere between, I don't know the exact values, but somewhere between less than 1 and more than 1. Or maybe just between 0 and 1. Does that make more sense? It doesn't really matter. Yeah, it's always less than 1. It should always be less than 1 if my math is correct in my head. But it doesn't matter. The point is that the magnitude, the strength of that vector in layman's terms, keeps changing. And that's why we get that, if I'm close by, I get a slow projectile. If I shoot far away, if my pointer is far away, I get a much stronger shoot out. I could change this, but I liked the mechanic a lot, so I kept it. So I just enjoy that mechanic, so I kept it. What I have to do is just this direction, I just have to convert it to a vector 2, then normalize it, and then use the shoot force, and then the shots will always be the same. This took a while to understand. I used my brother's help. He has a degree in math and computer science, so yeah. It was really cool to understand what happened here. All right, hopefully that was clear. That's shooting. Now let's do spinning. Yeah. Okay, if I'm spooting, I speed up, and if I'm not, I slow down. That's pretty much it. My rotation, I just increase it. If it goes beyond my maximum rotation, I make sure that I stay exactly at my maximum rotation, don't go overboard. Same exact thing with slowing down. If I'm leaving it, then it just slows down. Same thing. And then I spin, which I just use rotate, transform.rotate, which rotates you a certain amount So it just happens very, very quickly. Remember, this is an update, so it happens very quickly. It gives you the illusion of actually rotating, actually having rotation, though I do not have any rotation at all. Okay, I'm pretty sure there's a fixed, yeah, you see this? Fixed angle means that the Z doesn't actually change. If you get hit by something, if you get hit by the enemies coming into you, remember that the enemies actually don't have this. You see, they don't have a fixed angle. They actually spin around when I shoot them. When they are collided upon, they actually start spinning around, if you remember from the game design video that I showed you. The player, it doesn't happen. He has a fixed angle. He cannot spin around from getting hit by anything, by a collider or anything like that. The only thing that happens here is me just rotating it. And this happens so quickly, okay? It happens so quickly that it seems like it's actually spinning. Even though it's not really spinning, I'm just rotating it. And that's it. Now, I also have something that relates to shoot, but it's a function of rotation, so I put it here in spin instead of in shoot. Shoot delay is a function of rotation. Everything is a function of rotation. This is a little bit of a more crude function. Okay, 5 divided by rotation plus 6. That's just the way that I did it. You know, I'm going to take a sip of water. It's just the way I did it. I can play with the values here until I get different results and just see. I just play with it a little until I found something fun. But the way that it works, faster the rotation, lower the delay, faster we shoot. This goes up, this goes down, and then I shoot faster. Because the delay, the lower the delay, the smaller the delay, I shoot more faster, right? So bigger rotation, I shoot faster. That's what this line of code really does. That's spin. And that's pretty much it. That's done. These are just debug logs that are commented out because I'm not using them. That's Spooter. That's all I really do here in the Spooter that actually spins and shoots around. What I do have here is an action. In case you're unfamiliar with an action, this is an event. It's just a type of event. And I'm using on disable and on enable here. These are also basic functions that you should use if you're ever using functions. On enable when the script gets enabled, and on disable when the script gets disabled. Very simple stuff, right? So this thing, it's static, so I can call it from anywhere, and then anything that registered to this will be called. So that's just basic events. I'm registering spooting stopped, which is this function, which we'll see in a second. I'm registering it, and then anything that calls stop spooting, and what calls it is enemies when they hit me. Whatever calls this, I will run this function. Now guess what this function does? Spooting false. That's all it does. That's how we simulate letting go. We simulate letting go without letting go. We just spooting equals false. That's it. That's all it does. Hopefully you understood this. If not, go check out delegates and actions and events. That's just how it is. It's something basic. It has nothing to do with Unity. It's basic object-oriented programming in Visual Studio. Not specifically Visual Studio, just object-oriented. Okay, so that's Spooter. And now we know how Spooter works. I want to take a look at Bullet Destroyer. Okay, destroy game object. That's what Bullet Destroyer does. And this is a great time to actually talk about what collides with what. So I'm going to go into Edit and Project Settings, Physics 2D. So I'm using layers and the physics here. I hope you can see this lovely matrix nicely. It's important for specific stuff to collide with specific stuff. This is exactly what determines that. Bullets, as an example, needs to collide with destroyers. You see this? Bullets and destroyers do collide. Destroyers, however, cannot collide with the player character or with enemies or with the borders or with themselves. Destroyers' sole purpose is to destroy bullets, and that's why it's the only thing that they can actually interact with. Bullets can also interact with enemies, right? They can interact with enemies, but borders, they can't interact with. They go through the borders and into the destroyers, which are found just a little bit afterwards, and they cannot interact with each other because that will overload the system for no reason if bullets are overlapping, which can definitely happen. So there's no reason for this to actually be here. This is really important because it will overload your system if two bullets are just overlapping, which is really, really bad. So remember to remove that collision. Now, the borders, if we take a look at the borders, the only thing that the borders affect are the player character. right? Stretch my neck as it hurts. The player character and the borders are the only thing that can happen. These are player character and enemies. They also interact, but the enemies, notice that they are not interacting with the destroyers, and they're not interacting with each other. Again, if they overlap, we don't want to overload the system for no reason. And this is player character can actually be with another player character, but there's only one, so that doesn't actually do anything. This matrix is really important for this game. You need to make sure, first of all, for bullets overlapping and enemies overlapping will fry your system because they'll keep colliding and will kind of destroy all the other stuff that we're doing. I use collision a lot here, so it's important to be on top of what can collide with what. All right? Good. So yeah, destroyers will only destroy bullets because that's the only thing that they actually do. Borders are just box colliders, and because my player can collide with them, it'll actually stop him. Okay, I'll prove it. I collided with the border and couldn't continue moving. Right? Right. Lovely. So what else do we have here? We have the spawner. Let's talk about the spawner. So the spawner spawns enemies. Let's take a look at the enemy prefab. We've got enemy death, and we've got track. Oh, you know what? I forgot. Enemy death reminded me that we should talk about player hit, because the player, we didn't actually finish talking about the player. The player also has a nice little script called player hit, which has my hit points. And this actually, it doesn't determine death, which is important. It only determines my hit points. When my hit points reach death, I check that in my GUI, because my GUI is what actually sets, actually pauses the game. Okay, pausing the game is timescale equals 0. We'll see that. And it checks that the hit points are over 0. If they reach 0, I end the game. The game is over. So what player hit does is only check my hit points. Okay, I got a hit points. I got my hit timer because I have invincibility time. If you remember, when I get hit, I get invincible for a little while. That's why I also have the sprite renderer to change my color. And that's why I get it here at awake. On collision, okay, if I am not hit, if I didn't get hit, I'm not in a state of being hit, and I collided not with a border. This is important because remember, I can also collide with borders as the player character, and this is just for being collided with enemies, so not borders. I let Spooter know that I should stop spooting. That is the event that we talked about. I let Spooter know that we stop spooting, which will, spooting equals false. That's what it'll do. And I let the GUI know, this actually handles my score, that the player got hit. That's why I'm doing this. I'm letting the GUI know that it needs to reset the multiplier timer, okay? That's what it actually needs to do. So got hit equals true now because I got hit. The player renderer color, I change it. Okay, this is just a color. And then minus hit points. Okay, this could also be minus could be here. It doesn't matter. It's just, yeah. Death handling is done at Spooter GUI. It's important to note. This is a really important note. I mean, I note my text, my coding as I go, and I do put a lot of notes in there. Some people don't. That's terrible. When you code, please note your code. This is a very important note because you'd think that this should deal with death, right? You think that player hit, where you have hit points, should deal with death, but it doesn't in this case. Because I'm handling most of the pausing of the game in the GUI. And I'm not sure if it's the best way to do it, but that's the way I chose to do it. This only handles hit points. All right? All right, what do we got in update? Once we get hit, we start counting time. So once got hit is only when I actually got hit, I count time, and then I count an amount of time, okay, time. And when it passes the invincibility time, which is 2 seconds, okay? It was 3 and then I changed it to 2 and then 3 and 2, I don't know. It's game balance. I decided eventually to stick around with 2 seconds. Once it passes that time, got hit is false. I'm back to my normal state. I also changed my color back and my hit timer gets resetted to 0. So this is where I get invincibility for a little while. Note that while I'm invincible, I can't get hit again, so that I can clear the screen. If you remember that once you get hit, you can clear the screen by, having the enemies bump into you because you're invincible, you can't take damage. So that's how it's really done. It's very, very simple. So that's player hit. Now we can talk about the enemy. Enemy has 2 stuff, enemy death and track player. Enemy death, very similar to what we just saw. I have hit points. And when I hit, the first thing I check if it's the player. If it's the player, I just destroy myself instantly. The player also has collision and we'll check to lower its hit points. And if it's not the player, we'll go through this and we'll go down to here. We do minus hit points. So the minus actually happens before we check if it's equals 0. That means that the first time I get hit, I have 2 minus it's 1. Is 1 equals 0? No, so I don't destroy myself. The second time 1 minus it's 0. 0 equals 0, and I destroy myself. So I get hit once. The second time will destroy me. That's just what it does. It just destroys itself. That's all there is to it. And then I got track player. Track player tracks the player. I have the player. I get him. All right. Just get the player. And then I get the direction. We've done this before, right? No, we haven't. Never mind. It's very simple. You get it, and then direction normalized, and then 6, and that's it. And the reason this normalized is it's still vector 3 and a vector 2. So that is the same issue. But they always get... they're always at the same point. They're not always the same point. This actually means that they move faster a little bit. They move faster when they're farther away from you, and they come in a little bit slower, I think. Right? That's what I meant. But you can barely see it. It barely matters. So the problem permeated here, okay, because I implemented it in the same way. But you barely notice it because I'm setting your velocity instead of adding force. So you can barely see it, and it happens all the time. So that's just how I did it. It's a very simple way to do tracking the player down, and it works. So yeah, it works. All right, so that's the enemies. Now let's take a look at the spawner, which spawns the enemies. And this is kind of a cute thing. I could have had a lot of spawners, but I decided to go with just one that moves around because it's more comfortable to me to manage just one script and just one thing, just this thing instead of more spawners. That's just the way I found it more comfortable. Clearly I have the enemy prefab. I have the spawn delay and the spawn timer. This is the same thing that you've seen a million times before. I count time up, and once I reach the delay, I do the thing. In this case, it'll be spawning an enemy. I have, we'll talk about these constants in a second, which are the X size and the Y size of the screen, and the maximum spawn delay and the minimum spawn delay. Minimum is 0.4 and maximum is 1. So this is also going to be randomized. We'll see that in a second. Count time. If time is over delay, reset time. Delay is a range between the minimum and the maximum. So the spawn delay will keep changing, which is pretty cool. So, you know, 1 second, 0.4, somewhere in there. Not to always have the same thing, just because I can. And now we get the way that I actually did this. So what I actually did is I just tell the spawner to jump around to one of the 4 borders in a way, to either this border or this border or this border or this border. And I look at them clockwise. So this is 1, 2, 3, 4. Okay. It jumps to one of these. And then it decided one of these 4, and then it, like, let's say it found this top one, and then it chooses randomly a location here, like this. The Y value is the same, the X value is what changes here, and then it spawns something and moves again. All right? So I choose a number between 1 and 4. Random range on integers, it's integers, so it's inclusive. The first number is inclusive, the last number is exclusive, so this gives us between 1 and 4. And then 1 and 4 again is clockwise, like I just explained. And in case of 1, it's this one. It's like this. I'm just putting up the border to show you because I have no visual cues. And I'm not sure if you could you actually see that border? I'm not sure if you could actually see this border. Hold on, I'll just do this. Could you see it? No, wait, no, that's the wrong one. That's the wrong one. I just want you to see it, and I'm looking at the recording, and I see that you can't see it. All right, there you go. I made it bigger. Now you can see at least the numbers. It's just there. Okay, it's kind of often in acting weirdly, but you understand that it's this one because there's no visual cue. It's this one is what I'm talking about. You can see my mouse moving. So the Y value is the same. It's always the same. It's always that. And the X value is between minus and plus. Because you got to remember that, you know, this one is at 7.75, and this one is at minus 7.75, because the middle is 0, and the right direction is plus, and the left direction is minus. The same thing for up and down. So I only have, I chose a little bit, it's a little bit after the borders and the destroyers, just a little bit after, kind of outside the screen, 8.1, and the Y values are 4.85, so here it's 5.1. Kind of arbitrary, doesn't really matter where they actually spawn. So Y value stays the same. I random between minus X and plus X, and that's it. And I put that into my current position. Okay, so the spawner itself moves around according to the case, and then I instantiate the prefab where I am. That's it. Instantiate the prefab. And just to see that in action, which is kind of cool, take a look at the spawner and where it moves around. Okay, take a look at the spawner. You can see that it just moves at random intervals. It moves and spawns. Move, spawn, move, spawn, move, spawn, move, spawn, move, spawn, move, spawn. All right, in the 4 borders. That's it. It's kind of cool. Clearly, you could make a lot of spawners. You could. All the values are changeable. You can do whatever the hell you want. That's just the way that I decided to do it. More manageable in just one place. Have we gone over everything? Bullet Destroyer, yes. Enemy death. We talked about enemy death. Player hit. We talked about a spawner. We talked about a spooter. Track player. And now all that's left is Spooter GUI. We reached the most horrible thing. I have to take a sip of water. The GUI is terrible. Please excuse me. It is terrible. It is horrible. You should never ever use the basic Unity GUI. You should use one of the plugins, either NGUI or Easy GUI. What really will come in Unity 5, I'm currently using the latest version of Unity, which is 4 point whatever. In Unity 5, we should have a revamped GUI system that does not suck, but currently the GUI definitely sucks and is absolutely disgusting. I'm going to show you some of it because I'm using the GUI to show the score, so I want you just to see that. But it's really, really disgusting and very, very, it's disgusting. I'll show you how. I'll show you the how scene. You see this? You see this disgusting scene? Actually maximize. Let's do maximize on play. And you see how everything works and is nicely. But if I don't do maximize on play, actually you see that everything is completely screwed up because the way that the GUI works, it's really bad, guys. It's really, really, really bad. And these are just arrows placed here, and there's just the GUI. It's disgusting. So I'll show you it, but I'm ashamed of showing you the how GUI. So this is the how GUI. It's not the Spooter GUI yet. I just want to show you the how GUI. Look at this. It's disgusting. I just found the correct values for each thing. It's grunt work. It took me like 20-30 minutes to just find, I put the arrow where it should be, and then I just move the text until it's fine. It's disgusting. It's a horrible way. You should never do this. Unless you're making a game in 2 days, then it's okay. That's the only correct reason to do it. You know what? Even then, this is terrible. I feel ashamed for using this, but it worked for my purposes this time. It's icky. It's really, really icky. And the menu GUI, for the menu, I don't really have a lot to show you because it's just, application load level for the specific things. The menu, it has my logo and that's it. It's just basic GUI. This just sends you to the how, and this sends you to actually playing. So back to game, and I'll show you the Spooter GUI. Most of it is disgusting. I'm going to skip through most of it. I need to have the player Spooter in order to know the rotation and the location of it. The rotation and the location, we'll see that. I need to have the player HP in order to know when the game is over, when it reaches the HP 0. This is my score, the score timer, the score multiplier. You've seen this like 4 times up to this point, the timers. These are all GUI styles, and this is a timer, a global timer that you have at the edge just for the sake of having it. I get the, find the player on awake. I just do this in terms of player and player HP. I just get those. These are all styles, terrible. And my timescale, I make sure that it's 1 because I might be coming from time.timescale is a static element, so it persists throughout scenes. And I might be coming from a paused state because when I end the game, I pause the game, so I do timescale equals 0, and then I need to make sure that when I enter the scene, when I reload it, timescale is 1 because the game needs to run instantly. So I just put this here to make sure that if we come from game over, we start instantly. Okay, update. We have a counter. It counts the time. We also have another counter that takes into consideration if the game is paused and if I'm actually spooting right now. This is the score timer, the multiplier timer. It's the score multiplier timer, really. It only goes up if I'm spooting, if I'm spinning around. It does not go up if I'm not spooting, which is really important. We have pause the game if you press P or space or escape, and if the game is not done. This is really the check if the game is done. Instead of having a boolean or anything like that, I just check my hit points. If the hit points have reached 0, the game is over. That is the check that says, is game over? Okay? So, if the timescale, if I pause the game, this is pausing the game, timescale equals 0. If it's equal 0, I make it so that it's 1, and I enable my player spooter, which is my spooter, my actual movement and shooting. And if it's 1, then, which means the game is running, I pause it. Okay? And I disable the player spooter. And now we reach on GUI! Hooray! Okay, this is the timer. This is get current position and put up the hit points. I need to get my current position because my hit points are always going to be on top of my position, so that's why I need to find it. Set button, layer, not layer, style, whatever, blah, blah, blah. Pause game information. When I'm paused and the game is not over, so I can only pause if the game is not over, right? If the game is over, I don't want to be able to pause, even though timescale will be 0 because the game is essentially paused, but not in the state of being paused. It's game over. I hope I did not confuse you right there. Yes, so this is pause. This is game pause. You can resume it, which just does the exact same thing as here, I guess. I replicated code. I must be crucified. You must burn me at the stake. I should make a function with these 2 lines of code. So if you have code duplication, you should make a function. But it's 2 lines. Shut up. Application.load level. Go back to the main menu. If you press back to menu, this is the pause menu. And here I finally reached the important area where I actually wanted to show you the score. I just show the score, okay, score to string. And the multiplier is really just a function of the score timer, okay? I don't really need this variable, but I made it anyways. It's score timer divided by 3 plus 1, so if it's between 0 and 3, it'll be 1, and if it's between 3 and 6, it'll be 2. Every 3 seconds, your multiplier goes up by 1. Pretty simple. And if we're spooting and we're actually playing the game, the score goes up, right? If we're spooting and we're not paused, the score goes up. And it is rotation divided by 10 times score multiplier. I could put anything here. I could put absolutely any kind of function that you want here. As long as the score goes up and there's a multiplier, you can do whatever the hell you want here. You can add plus 100 or whatever. It doesn't really matter. That's just how I calculated the score. It works, you know? So death, this is how I actually handle death. Remember that I said I handle death here because it relates to score and I use GUI in order to show it. Player HP dot hit points equals 0. Then this is essentially pausing the game. I do false and the time scale is 0. And then I show game over, final score, play again, back to menu, blah, blah, blah. One last thing that I need to point out. When I get hit, I need to reset the score timer. This is another event that gets hit. Remember when we have player hit, we send out spooter GUI.player hit, right? We sent that to show that we got hit and that the score timer needs to reset because it's really the multiplier that gets reset and it's a function of score timer, so that's how I reset it. Notice here that I set up score for enemy killed, right? So when I kill an enemy, the score will not be reset, will rise somehow. But I just didn't do it. I just left it. I just didn't do it. I just didn't get around to it, and I didn't really care, and it works. So when you kill enemies, you don't actually get a boost in score. It doesn't really matter because the game works, you know. It'll just inflate the score. That's really what it does. It's not really an element of gameplay because you kind of kill the same amount. Clearly, you know, they come out in different ways because you have different delays. But that's just I just didn't do it. I just didn't add here anything. I set up for it, but I didn't actually do anything. What I'd need to do if I want every enemy hit to give me score is when they get destroyed, call this function. Okay, just call this function. That's it. Spooter GUI dot enemy killed, and this will call this function and run whatever. And that is it. That is it. That's how I made this game in Unity. I hope this has been interesting and helpful as a tutorial or just whatever. Just look at my code, and I hope my code is not too horrible and burned your eyes. And that's it. I made this really in 2 days of on and off work. I had a lot of fun doing it. I liked the result. I like the game. I think it's pretty cool. There's a ton of things that you could do. Okay, there's just so many things that you could think about and change the mechanics here and there. And, you know, there's so many things you could do with this. But that's just how I made it. Again, 2 days on and off, so it's not the most amazing thing. And that's it. I hope this has been helpful. Thank you so much for watching and sticking around with me. If you have any questions, let me know. Either send me an email if it's a long one or just leave me a comment. I do take a look at every single comment, as much as I can at least. And yeah, that's it. Thank you so much for watching, and I'll see you guys next time. Bye.